Okay, today I want to go over section 6.3, which is volume by cylindrical shells. We already talked about volume using the disk method and volume using the washer method, where in the case of the disk or the washer method, the rectangular strip is always perpendicular to the axis of rotation. Okay, just to remind you, a rectangular strip is always perpendicular to the axis of rotation. Sometimes that doesn't work. Let me explain that. If I say to find the volume generated by the solid obtained, so let me write this down. To find volume of solid obtained by rotating about the y-axis, the region bounded by the graph of y equals 4x minus x squared and y equals 0. If you do a sketch of that, a rough sketch, 2, that's a 4, so you can put it in your grapher, and you're gonna somewhat like this in the first quadrant, and you want to take this region and rotate it about the y-axis. So if we were to use the washer method, we would have to do a rectangular strip perpendicular to the y-axis, because the y-axis is the axis of rotation. And if we do that, then we're gonna have to find the width of this, which means we have to for x in that equation is a quadratic equation in x where you have a y, which is not an easy task. Okay, so that method doesn't work all the times. Again, you're gonna have to isolate x, solve for x, because you're going this way. So that's why we have a need for another method, and that other method is called cylindrical shells. So let's talk about that. The cylindrical shells. Okay, so I'm not gonna write down everything I say, because it's all in the notes. So you should be listening to the lecture while you have the notes in front of you. So in the shell element, we will revolve rectangular element or rectangular strip or a cross section about a line parallel to the element. So whether it's the y-axis, the x-axis, or any line, vertical or horizontal, the cross section or the strip that we're going to use is going to be rotated about it's going to be parallel to the axis of rotation, parallel, and that's going to generate a hollow shell. It's going to generate a hollow shell. So if you take, just as an example, if you take any function y equals f of x between x equal a and x equal b, and you want to rotate about the y-axis, so you take a cross section parallel, this is parallel to the axis of rotation. That's the difference between shell and washer / disk method. In this case, the axis of rotation is the y-axis. Okay, so if you do that, you see you're gonna get a hollow shell, and that hollow shell, let me just graph that as much as I can. So you're gonna get somewhat like this. Again, this is not the best one to draw, but it's okay. I'll do my best. Anyway, somewhat like this. So basically, you're gonna have the height of the shell, and you have R1 and R2, like the radius of the outer cylinder and the radius of the inner cylinder. So R1 is the bigger one, and R2 is the smaller one. So the volume of the shell, the volume of the shell with outer radius R1 and inner radius R2. So it's going to be the volume of the outer cylinder minus the volume of the inner cylinder, which would be, remember, volume of the cylinder is pi times r squared times h. So pi r1 h is the height, and then pi r2 squared h, which would be written as pi r1 squared minus r2 squared, and then so I factored out pi h, and this is the difference of two squares, r1 minus r2, r1 plus r2 h. So I want to divide by 2, so I'm timesing and dividing by 2 for a reason. So this is called the average radius, r1 plus r2 over 2, average radius of the cylinder, of the cylinders, of the top of the cylinder or bottom. And then this we would say V equals 2 pi r, that's r, and this is delta, the change in r, as we know, like delta x or delta r, and then h, or 2 pi r h delta r, where 2 pi r is the circumference of that circular top or bottom, and h is the height, and delta r is the thickness. So this is just an example. Now we can generate this for any solid, and I'm not going to write down all the details, but I'll give you roughly, because it's all in the notes. So in general, if S, so if we're not just talking about a specific graph, in general, S be the solid obtained by rotating about the y-axis or the x-axis. We're gonna, it's similar. The region bounded by y equals f of x. F of x is greater, so we're talking about above the x-axis. Y equals 0, x equal a, x equal b, where b is greater than a is greater than 0. Then we're going to use Riemann sums. Again, I'm not going to go over all the details. So basically we're going to do, so you have y equals f of x between x equal a and x equal b. So we take a strip, instead of r1 and r2, it's xi minus 1 xi, and if we rotate, we're gonna get that cylinder. So you can see the height is f of x, and then r2, r1. Okay, so this will give you the volume. So VI, the volume of that strip, it's gonna be 2 pi, just like what we did. It's gonna be 2 pi, and then we're gonna use x, or x, whatever you want to call it, xi bar, that's what they call it, which is xi1 plus xi over 2, just like r1 plus r2 over 2, so 2 pi. It's gonna be xi bar, and then delta r is your delta x, and h is f of x, or f of xi bar. And so the v would be using Riemann sum, which is sum of 2 pi xi bar f of xi bar delta x, which would be the integral from a to b 2 pi x f of x dx. And that's so. And if we're rotating about the x-axis, then it would be 2 pi from c to d, y values, y f of y dy, y-axis or any parallel line. Okay. So this is how we find the volume of the solid using Riemann sums, and we're gonna practice this with examples, but keep in mind using the shell method is rotating about a parallel axis, not perpendicular. So example, use the shell method to find the volume of the solid formed by revolving the limited by y equals square root of x, y equals 0, x equals 4, about the y. So if you look at graphing grid, y equals square root of x, so it's gonna be 0, 0, 1, 1, 1, 2, 3, 4, 2, and then you want x equal 4, that's x equal 4, so y equals root x, and y equals 0, which is the x-axis, so you want this region and you want to revolve around that, so you take a strip. Okay, so b equals 2 pi integral from 0 to 4, right? We're going to cover all this, x, and then f of x, this is f of x, which is square root of x dx. So it's 2 pi integral from 0 to 4 x to the 3 halves dx. So pi x to the 5 halves times 2/5 between 0 and 4. 4 pi over 5. 4 to the 5 halves is 32, which is 128 pi over 5 cubic units. Okay. Go to page 465 in your text, number 4. Page 465, number 4. Okay, they have the graph for us. It says a solid is obtained by rotating the shaded region about the specified line. Part A. Set up an integral using the method of cylindrical shell for the volume of the solid. So basically, we're going to rotate about the x-axis. I'm going to rotate about the x-axis. So basically, if you take, this is the graph I copied it here, so I don't want to rotate it about the x-axis. So you're going to go all the way down to y equals 0, all the way up to y equals 1. So we're going to do 2 pi integral c to d y of y dy. So 2 pi, the minimum y is 0, the maximum is 1. And then f of y, you're going to go from from here to there. So it will be x equal 2 minus y, outer minus inner, and then x equal y squared. So 2 minus y squared, outer, inner, dy. and that would equal 2 pi integral from 0 to 1 to y minus y squared minus y cubed dy, 2 pi y squared minus y cubed over 3 minus y4 over 4, 0 to 1, 5 pi over 6 cubic units. Okay. And the next one I want to do is number 12, page 465. Number 12, page 465. Use the method of cylindrical shells to find the volume generated by rotating the region bounded by the given curve about the y-axis. So we're rotating about the y-axis. The region is y equals e to the negative x squared, y equals 0, x equals 0, and x equals 1. So if we graph y equals e to the negative x squared, if this is a 1, so it's gonna go like this. You can put it in your grapher, y equals 0, this is y equals 0, x equals 0, and x equals 1. So we're going to take this and we want to revolve it about the y-axis. So it's going to be this way. So v equals 2 pi from a to b x f of x dx. 2 pi integral from a to b. So we're going from 0 to 1, x equals 0 to x equals 1. We're going that way, so it's going to be x and then f of x e negative x squared dx. Okay. And if we integrate, so v equals, you can use u substitution, so you let u equals negative x squared, so du is negative 2x dx. So you have 2x dx, you need a negative. Pi integral 2x dx is du, and then e to the u, which is negative pi e to the u, which is negative pi e to the negative x squared from 0 to 1. And that's how you get pi 1 minus 1 over e. So I'm just trying to do as many different kinds of examples as possible. 18, page 465. It says again, use the method of cylindrical shells to find the volume of the solid obtained by rotating about the x-axis. So rotating about the x-axis. X equals negative 3y squared plus 12y minus 9, and then x equals 0. And if we graph this right here, x equal negative 3y squared plus 12y minus 9, x equals 0, so x equals 0 is the y-axis. And this, if you if you see where this crosses the y-axis, it crosses the y-axis, x equals negative 3y squared plus 12y minus 9. It crosses at minus 4y plus 3. So it crosses at 3 and 1. And you can find the vertex. We don't really care, but it's going to be somewhat like this. And since we're revolving about the x-axis, we're going to get a strip. So we're going to measure this strip. This is my f of x. So x equals negative 3y squared plus 12y minus 9. So we have that. We're revolving about the x-axis. And going from y equal 1 to y equal 3. So 2 pi 1 to 3 y, f of y is 3y squared negative plus 12y minus 9 dy. So let's put that in here. So v equals 2 pi from 1 to 3 y negative 3y squared plus 12y minus 9 dy. So on the test, you gotta show all the details like I'm doing right now. I'm not gonna, if you do this and you just show me an answer, you're gonna lose a lot of the credit. You have to know how to integrate. 1 to 3 negative 3y cubed plus 12y squared minus 9y dy. So if you integrate, you get negative 3y to the 4 over 4. That's 12y cubed over 3 is 4y cubed. Negative 9 over 2y squared between 1 and 3. And you end up with 16 pi cubic units. Now I'm going to do 22. Page 465. It says the region bounded by the curves is rotated about the specified axis. Find the volume of the resulting solid using x as the variable integration and then y as a variable integration. So first we're going to use x as a variable of integration. And that region is, let's graph it. So we have y equals x cubed, and then y equals 4x squared. So y equals x cubed, it goes through 0, 0, 1, 1, 2, 8, 2, 3, 4, 5, 6, 7, 8. So this is y equals x cubed. And then 4x squared, 0, 0, 1, 2, 3, 4, 1, 4. And then we do 2, it will be 16. So basically it's going to be like this. And they're going to cross, we can see where they cross, at y equals 64. So it's somewhere there, but I'm not, they're going to cross at y equals 64. So we're looking at this. So let me do a better graph than this. This graphing paper limits you sometimes. So basically you have two graphs. This is y equals x cubed. This is y equals 4x squared. They intersect at 464. If you just set them equal, x cubed equals 4x squared, x cubed minus 4x squared equals 0. So you know they cross at x equals 0, x equals 4, but when x equals 4, y equals 64. So we want this, the volume of rotating the strip first, using x as a variable of integration. So we are revolving about the y-axis. No, if using x revolving about the x-axis, we're using the washer method. So we're using the washer method. because if we're revolving about the x-axis, that's perpendicular to the axis of symmetry, so using washer method. So it will be, remember, outer minus inner, pi, integral from 0 to 4, and then the outer square, pi r1 square, which is 4x square minus inner square dx. So pi 0 to 4, 16x4 minus x6 dx, which is 16 over 5x5 minus x7 over 7, 0 to 4. And if you do the math, that's what you're gonna get, cubic units. Now if you use y as a variable of integration, part B, you use y variable of integration. So that means you are going to also rotating about the x-axis. Okay, so we're gonna have to do a parallel, and that means we have to solve for x. This is x equals cube root of y. This is x equal square root of y over 4. Okay, and we're going from y equals 0 to y equals 64, 2 pi c to d y f of y dy. So 0 to 64 y, and f of y, it's going to be cube root of y minus square root of y over 4. Which is a half square root of y dy. Square root of y over 4 is root y over root 4, which is that. So it's 2 pi 0 to 64 y to the 4 thirds minus 1 half y to the 3 halves, which is 2 pi, that's y to the 1 7 thirds, so 3 7, 1 half times 2 fifths y to the 5 halves, 0 to 64, which is obviously the same answer. Pi. Again, it's all cubic units. 28, page 465. It says use the method of cylindrical shells to find the volume generated by rotating the region bounded by the curves about the specified axis. So y equals root x equals 2y, and we're going to rotate about x equals 5. So y equals root x. Okay. So 0, 0, 1, 1, 4, 2. And then x equals 2y. X is 0, y is 0, y is 1, x is 2. And then x is 4, y is 2. So that's 1 and that's the other. So this is y equals root x. This is x equal to y. They cross at 4, 2. So we went out of this. So let me get a better graph for this. I don't like this graph paper. I gotta do another one. Anyways. So 0, 0, 1, 1, 2, 3, 4, 2. This is y equal root x, and then x equal to y. y equals root x, x equals 2y. So we want to take this and rotate it about x equals 5. So we're going this way, about x equals 5. So v equals 2 pi integral from 0 to 4, right? From 0 to 4. We're going to cover all this area. And then we want this distance, which is 5 minus so that's 5 minus x, right? This is x. That's 5. So it's 5 minus x, and then this one, if we want this height, it's gonna be root x minus x over 2 dx. So it's 2 pi 0 to 4, 5x to the 1/2. I'm foiling this, minus 5 over 2x. So x to the 3/2 plus 1/2 x squared dx, which if we integrate, it's going to be 10/3 x to the 3/2 minus 5 over 4 x squared minus 2 over 5 x to the 5/2 plus 1 over 6 x cubed from 0 to 4, which is 136 pi over 15 cubic meters. Okay, number 50. 50 from page 466. It says, a solid is obtained by rotating the shaded region above the specified line. Set up an integral using any method to find the volume of the solid. So this is a graph, and to find the volume, this is a graph to find the volume. You can do a horizontal strip, but you can do a horizontal strip, then to use washer, but then you have to split up, or you can do a vertical strip to do shell, but you don't have to split up. If you do a vertical strip, it's gonna be, so if you use the shell method, it's 2 pi integral of x f of x dx, where we're gonna go from, we're doing a horizontal strip, so we're going from 0 all the way, no, we're doing a vertical strip, so we're going from 0 all the way to 3, because that's where they cross. Look, 4x minus x squared equals x. So x squared equals 0. So they cross at x equals 0 and x equals 3. That's how I know. Okay. So 2 pi integral x and f of x. So we want to find that strip. So it's going to be 4x minus x squared minus x dx, and you integrate it, 2 pi 4x squared minus, so let's do 4x minus x is 3, so 3x squared minus x cubed dx, which is 2 pi, then it will be x cubed minus x4 over 4 between 0 to 3, 27 pi over 2. 27 pi over 2. And that's it for 6.3. Until 6.4, have a good day.